Hi students, welcome to Physics A level classes. Today we are going to discuss the previous year question paper related to in October 2021. It is the second part of question paper discussion. Okay, so now we are going to discuss the question 11th question. Okay, a toy car is released from rust and rolls down a slope as shown. Okay, the mass of the car is 0.16 kilogram and the speed of the car at the bottom of the slope is 2.6 meter per second. First of all, we have to calculate increase in kinetic energy of the car as it accelerates down the slope. Okay, so what are the given data? Okay, first of all, now we know that the car is released from the rust. Okay, so it is released from rust. That means its initial velocity is zero. Okay, since the car is released from rust, its initial velocity is zero. We know that the kinetic energy is the energy which is due to the velocity of a particle. Okay, so the initial kinetic energy of the car is also zero. Okay, it is a clear idea. Then what about the final kinetic energy of the car at the bottom of the slope? The final kinetic energy, it is nothing but kinetic energy. The expression for finding the kinetic energy is equal to half mv square, where m is the mass and v is the final velocity of the or speed of the car at the bottom of the slope. Okay, so we can use this expression to calculate the kinetic energy. Okay, so the kinetic energy is half into mass into velocity square, where mass is given as 0.16 and the velocity is equal to 2.6 meter per second. Okay, so we will get the kinetic energy is equal to 0.5408 joule. Okay, it's a SI unit of kinetic energy is joule. Then the second part of this question, as the car accelerates down the slope, the work done against the friction force is given as zero point 0.6 joule. Calculate the vertical displacement of the car. Okay, we can represent the total motion of the car as this. It is a slope area. The car is initially at the topmost position, and at the final, it reaches the bottom of the slope. Okay, then we can take the height of the slope as EH, right? Then what about the energy carried by the car at the top? That the total energy of the car at the top of the slope is nothing but it is the potential energy of the car. Okay, since the initial condition of the car, it is in rest, so there is no kinetic energy. The car has no kinetic energy at the initial position. So it's the total energy of the car is nothing but it is a potential energy. Okay. Actually, we know that the potential energy of the car, with the reference to the horizontal plane, its is equal to potential energy is equal to mgh. Okay, it is an expression for change in potential energy or potential energy of the car at a height h, which is equal to mgh. Okay, then what happens to this total energy when the car reaches the bottom point? Okay, according to the conservation of energy conservation principle, the total energy at any position is remains constant, right? Energy can neither be created nor be destroyed. So the total energy of the car at any position will be same. Okay, then, but as the car moves down, some frictional forces, that means some energy losses in this motion. Okay, that means some energy is lost due to the frictional forces. This is given by 0.26 joule, right? So what happens to this potential energy of the car at the topmost point of the slope? Okay, this potential energy actually it is converted to the kinetic energy of car. At the same time, some of the energy is lost due to the frictional forces. Okay, so we can written as the potential energy of the car at the highest position is equal to the kinetic energy of the car at the bottom plus the energy losses. That means the total potential energy is converted to two energy during the motion. That means the kinetic energy of the car and some energy losses due to the frictional forces. Okay, so we can substitute instead of the potential energy at the highest point of the car is the as mgh. Okay, and from the first part we already calculate the kinetic energy of the car at the bottom. So it is 0.5408 joule, and the energy loss due to the frictional force is given by zero point 0.26 joule. Okay, so we get mgs is total mgh is equal to uh, 0.8008 joule. Okay, so we can easily find out the value of h, the height. H is equal to 0.8008 divided by m into g. Okay, then what about the m? M is already given. It is a mass of the toy car. Okay, it is 0.16, and g is acceleration due to gravity. It is nothing but 9.81 meter per second square. Okay, finally we get the value of h, height as 0.51 meter. Okay, so we can say that the height is equal to 51 centimeter, right? Okay, question 12. An aluminum sphere collides head on with a stationary steel sphere. It is the steel sphere is stationary. Two spheres move off separately after the collision. Two spheres move off separately after the collision. Okay, separately after the collision, right? State the principle of conservation of momentum. Okay, so, conservation of momentum, it is nothing but the law of conservation of linear momentum states that when two objects collide in an isolated system, the total momentum before and after the collision remains equal or same. Okay, how we can explain this one? Consider it is a body, first body of mass m1 and whose initial velocity is u1. It is moving in a horizontal direction with a velocity u1, and now we are consider another mass m2 and moving with a initial velocity u2. And if u1 is greater than u2 and they are moving in the same direction, then it will be collide to each other. Okay, so after the collision, the velocity of first mass becomes v1 and the velocity of second mass becomes v2. Okay, then how we can apply this conservation of linear momentum in this condition? Okay, it is nothing but it is m1 u1 plus m2 u2 is the total momentum of the system before collision. Okay, which is equal to m1 v1 plus m2 v2. Okay, m1 v1 plus m2 v2, it is the total momentum of the system after the collision. Okay, we know that that momentum is nothing but it is a product of mass and velocity, right? So we can say that the total momentum before collision is equal to total momentum after collision. Okay, right? Then the second part of the question 12. The aluminum sphere has an initial velocity 10 meter per second. Immediately after the collision, the velocity of steel sphere is 5 meter per second. Okay, and they show a figure the condition of before collision and after collision, right? Then calculate the velocity v of aluminum sphere immediately after the collision. Okay, they give the mass of aluminum and the mass of steel ball, and the initial velocity of the steel ball is nothing but that is 10 meter per second. That is, we can take it as u1, right? Then what about the u2? Since the steel ball is initially rest, so its initial velocity is u2 is equal to 0. And what about the final velocity of aluminum? It can be taken as v1, and v1 is equal to v. We have to find out this final velocity of aluminum, right? And what about the velocity of steel after the collision? We can take it as v2, right? v2 is equal to 5 meter per second, right? So which equation we have to use? We have to, for any collision we can apply the conservation of linear momentum. That is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, here we can take the m1 as 2.7 kilogram, and the m2 as m2 is equal to 7.9 kilogram, right? So now we have to substitute these values in this conservation of linear momentum equation, right? So we can substitute for m1 we can substitute 2.7 kilogram into 10 meter per second in plus the the second mass of the steel bob is nothing but 7.9 into whose initial velocity is 0, which is equal to, that is the total momentum before collision. And what about the total momentum after collision? It is equal to 2.7 into velocity v, it is the velocity of aluminum. We have to find this velocity, and the momentum of steel after the collision is equal to 7.9 into 5 meter per second. Okay, so now we have substituted all the values in this equation. Okay, now we can solve. That is, this part is come to zero because the initial velocity of steel is zero. Total part is zero. So we can simplify it as 27 is we will get 27 is equal to 2.7 into v plus 39.5. Okay, now we can take the 39.5 into the left hand side of the equation. So we will get 27 minus 39.5 is equal to 2.7 into v. So easily we can calculate as minus 12.5 is equal to 2.7 into v. So the velocity of aluminium after the collision v is equal to minus 12.5 divided by 2.7, and finally we got the velocity v is equal to minus 2.63 meter per second. Okay, then what about the meaning of minus? Okay, minus sign. That means the steel is moving in a forward that is right horizontal direction towards the right, and since the velocity of the aluminum is the negative sign, so it will move just opposite to the direction of steel, right? Okay, after the collision the aluminum bob the aluminum sphere moves just opposite to the direction of movement of steel. Okay, right, that's the just meaning of the negative sign. Okay. Okay, question 13. A sludge accelerates due to gravity from the rest. Again, the movement starting from the rest, right? Okay. Rest down a frictionless slope. Okay, it is a frictionless slope, so there is no frictional forces, and the air resistance can be ignored. That means there is no energy losses in this total motion. That is because there is no frictional forces and no resistance of air. The slope is at an angle 6.9 degree to the horizontal as shown, right? First of all, we have to draw the complete the free body force diagram below for the sludge. Okay. First of all, we have to consider what are the forces acting on the sludge. Okay, we know that for any body whose weight is always acting, weight is always acting vertically downward. Okay, weight is always acting vertically downward. Okay, the weight is equal to mass into acceleration due to gravity, right? Where m is the mass of the sludge and g is acceleration due to gravity. Okay, so now we know the weight. We complete the first part. Then what about the second? The since the sledge is on a horizontal on a inclined plane, the plane is always acted a normal reaction to the sludge. That means the direction of reaction force from the inclined plane is always perpendicular to the plane. Is always the reaction force from a plane surface is always perpendicular to that plane. Okay, so the normal reaction Rn is always perpendicular to the inclined plane. Is always that is perpendicular means is the 90-degree to the inclined plane. Okay, right? Then there will be some. Now we can resolve. That means this perpendicular and the vertical is always making an angle theta. Okay, if the angle of inclination of the plane is theta with the horizontal, then again the normal reaction is also making theta angle with our vertical weight. Okay, from the weight. Okay, right. Then now we can resolve the weight into two components. One is one component which is parallel to the plane, parallel to the inclined plane, and another component which is perpendicular to the inclined plane. Okay, how we can resolve? Because this angle theta is with the weight, so the cos theta sin theta component will be the parallel component. Okay, parallel component with the inclined plane. Okay, that is mg sin theta. The sin theta component of weight is acting parallel to the inclined plane, and mg cos theta will be acting perpendicular to the inclined plane. Okay, these are the forces acting. Okay, and also we know that the sludge is accelerated due to gravity. That is, the sludge is moving downward direction with an acceleration. Okay, this acceleration we can take it as a. Okay, and it moves down, right? It is moves down due to the um, gravity. Okay. Okay, so we can now we know the all the forces acting on the sludge and the direction of acceleration. Okay, right? So we can just draw the free body diagram. Okay. First, we can draw the two components of weight, that is mg sine 6.9 degree, which is always parallel to the inclined plane, and mg cos 6.9 degree, which is always perpendicular to our inclined plane. And there will be one normal reaction, which is also perpendicular to the normal plane. Okay, and finally, the acceleration is always parallel to the plane and the downward direction. Okay, parallel to the plane and the downward direction. Okay, these are the main components or main forces acting on the sledge and the condition of motion. This is a free body diagram, right? Now we are moving to the second part of this question. The slope has the total length of 60 meter, right? Show that the initial acceleration of the sludge along the slope is about 1 meter per second square. Okay, how we can find the acceleration? Okay, so first of all, we have to consider the free body diagram once again. Okay, right? What are the forces acting? Weight, the weight, two components of weight is shown, mg sine theta, which is parallel to the inclined plane, and mg cos theta. If we are taking theta as 6.9, then mg sine cos theta is acting perpendicular to the inclined plane, and there is a normal reaction, and the acceleration is always parallel to the inclined plane downward direction. Okay. Now we have to recall the Newton's second law of motion. What is the Newton's second law of motion? If there is an acceleration in any direction, then the resultant force in that direction is the inertia times its acceleration. Okay. Okay, here, which is the direction of acceleration. The direction of acceleration is nothing but it is just parallel to the inclined plane. That is also already we shown, right? So now we have to consider the and whatever the mathematical expression for that Newton's second law. If x is the acceleration in x direction, then sigma fx is equal to m into x. Okay, that is the resultant force is equal to mass into acceleration. Then what are the forces acting parallel to the plane, inclined plane? There is only one force acting in parallel to the inclined plane, that is mg sine theta. That is the sine theta component of the weight, right? So we can write easily the resultant force in the direction of acceleration. It is nothing but it is mg sine theta. So according to the Newton's second law, mg sine theta is equal to mass times acceleration. That means mass is nothing but it is the inertia. Okay. So from this expression we can cancel the mass. So we will get g sine theta is equal to the acceleration. Okay, so we can easily find out the value of acceleration. Okay, how we can find out the acceleration? We can substitute 9.81 in the in place of acceleration due to gravity, and we know that the angle theta is equal to 6.9. So we will get the value of acceleration. Okay, that is the value of acceleration is equal to 1.18 meter per second square. Okay, it's approximately 1 meter per second square, right? Okay, now we are moving to the next part. Okay, determine the speed of the sledge at the end of the slope. Okay, right? And what are the given data? Okay. Okay, we know the free body diagram of our sledge, right? Initially it is at the rest. Okay. And we know the total slope distance displacement is 60 meter. Okay, they're given the displacement of sledge, the total displacement is equal to 60 meter. And they also given in the question itself, it is the initial velocity u equal to 0, right? Then acceleration, it is already we calculated 1.18 meter per second square. Okay, now we have to find out the final velocity. Okay, since it is a uniform accelerated motion, there is no change in gravity with respect to this distance, so the acceleration will be uniform or constant throughout the motion. So we can treat this motion as a uniform accelerated motion. Okay, and now we know for a uniform accelerated motion the following equations. Okay, what are the equation? V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Okay, so from this equation, which equation we have to use? Actually, we have to connect the displacement SUAV, which is the expression. It is nothing but V square is equal to U square plus 2AS. Okay, so now we can use this expression to find out our final velocity, right? V is the final velocity, U is the initial velocity, A is the acceleration, S is the displacement. Okay, now we can substitute this those values, displacement, initial velocity, acceleration in this equation. So we will get V square is equal to 0 square plus 2 into 1.18 into 60 meter. Okay, so we know that this part is completely turns to 0. So finally we can find that V is equal to root of, it is V square. So V is equal to root of 2 into 1.18 into 60. Okay, finally we got V is equal to the final velocity is equal to 11.9 meter per second. Okay, now we are moving to the last part of this question. Okay, question 13. Determine the time taken by the sledge to travel to the end of the slope. Okay, then what are the related data we have? The initial velocity, we know the movement of sludge start from rest. So the initial velocity u is equal to 0. Okay, and we also already calculated the value of acceleration. It is 1.18 meter per second square, right? And already in second part, we already calculated the final velocity of sledge at the bottommost point. The final velocity v is equal to 11.9 meter per second, right? Then now we have to calculate the time required to move the sledge from the topmost point to the bottommost point of the slope, right? Okay. So again, we have to recall the equations for uniform accelerated motion. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Okay, right? Then which equation we have to use for this situation? That is the equation which should connect u, a, v and time. Okay, so it is nothing but it is the first equation itself, that is v is equal to u plus at. Okay, v is equal to u plus 80. Now we can substitute those values of this initial velocity, acceleration and the final velocity into this equation. So we will get 11.9 is equal to 0. Initial velocity is 0 plus 1.18, that is acceleration into time. Okay. So from this equation, since the initial velocity is 0, so it becomes 19.9 is equal to 1.18 into t. Okay. So we can find out the value of t by dividing the 1.18, that is 11.9 divided by 1.18 is the time. Okay, so finally we can calculate the value of time as 10.08 seconds. Okay. Okay, thank you so much.